Second lecture for week 7. This lecture is about global variables and static variables. Um, so, just a review of the scope things that we've already discussed. We know that whenever we declare a particular variable in a particular code block, that particular variable is not accessible outside that block, right? And now that we have discussed functions, you can understand that functions themselves are just another code block, right? So you can, whenever whatever variables you declare inside a particular function, that particular variable remains accessible within that function only, right? So the variables that we've been declaring till now, they usually fall into a storage class. Okay, the storage class that we have used till now is also known as the auto storage class. Auto stands for automatic. So if you don't give any other storage class, then the class is automatic, and the variables in this storage class have their scopes limited to the block in which they are defined. This is precisely the reason that if we want to pass the value of a particular variable to another function, we have to supply that as arguments, right? So you remember we saw those formal and actual parameters. So this is the reason that we have to pass the value of a auto variable from one function to another in order to use it. And this same problem is true when we are trying to return the output of the function, because let us say the variable which whose values we are trying to return back, if that particular variable was a local variable in the called function, then there is really no way to access it from the calling function. So that is why we have to return the value, and then in the calling function we have to use some local variable. This is what we did last week in the last lecture, that we used some local variable where the returned value from the function was getting stored so that we can use it. Now in some particular cases, the same value might actually has to be passed into multiple functions from the calling function, right? And this seems to be a kind of a inconvenient scenario. So in these kind of cases, there are some more storage classes which can help us. But before we go there, let us just consider a code example. So, let's start with this. So, this is basically an example where we are just trying to create two string related functions. So, string, if you remember, are just character arrays, but they are terminated with a null character. So we are now looking at creating two string functions, string utility functions. There is a function called trim. This function removes any leading and trailing spaces from a string, and there is another function called starts with, which basically checks if a particular string starts with a particular prefix. This is the idea, and you can see the declaration for both these methods. um, in fact, I should show you like this. So in the declaration you can see that in trim I require the string to be passed, and in starts with I require the string as well as the prefix that I want to check. So this is how the declaration for the two methods are. And let us say if we start with a string like this where there are some leading and trailing spaces. If we try to see if this particular string starts with hello, certainly this is going to produce false, because there is some leading and trailing space. And then the way we created this starts with function, it is going to return a 0 here. And now after we actually use the trim function, the leading and trailing spaces gets removed from this string. And if now we try to do starts with hello, of course, I mean, it would probably work with the hel, hell, as well as hello. So basically I'm just saying that if this particular string is a prefix of this particular string, and now if I try this, this should produce a 1. And if I run this program, this is exactly what it produces. Now, and by the way, these are the definitions for those two functions, trim and starts with. You don't really have to go into much details. The only thing that you should probably see is that I have to pass this str in both functions, because you need the string in order to operate over it. So now, this is something that we can probably avoid, right? Because this seems to be a wasted effort. I have to um, pass this str variable every time I call either trim or starts with. So a global variable in C, and this is not just related to C. It's basically a simple concept that is available in multiple languages, C++, even Java, Python, all those scripting languages. So they allow you to create certain variables which are called as global variables, okay, whose scope is global. So when I say global, what I really mean is that these variables are visible to all the functions in the program, okay, not just to a particular variable. So the way we actually create a global variable is that we define it outside all the functions, right? So we are not going to define it inside a particular function, not even main. Okay, we have to define it outside all the functions. This will make this the variable visible to all the functions defined after its definition. So the order is very important, right? I mean, the place where you define it, everything after that, it is going to be visible. Of course, if you want it to be visible for to the functions that are defined before its definition, you can always add an explicit declaration, right? So we keep going back and forth from that declaration and definition thing. So similar to a declaration of a method, you can also have declaration of these global variables, but usually, okay, and by the way, if you want to do that, there is a keyword called extern. You can use it, but this extern keyword, I'm not going to go into much details of it, because it's only useful if you are planning to split your code across multiple C files. And we haven't really done anything like that. We haven't really written any code which deserves to be split across multiple files. So as long as you are actually going to use this global variable within the same file, it makes sense to simply define it at the top, right, in the beginning, so that you don't really have to give any kind of declarations. And that is why, if you are working with single C files, the extern keyword is not really something that you really need to know about. So anyhow, so coming back to the example, what we are going to do is we are going to make the str variable global, right? So this is what I'm trying to say, that now I have defined this str variable outside all the functions, even outside the main function. So now what happens is the scope of str becomes global. And the two functions that I have defined, trim and starts with, their declarations too changed, right? Because I no longer need char asterisk here, char asterisk str here, and char asterisk str here. So the number of arguments that these functions now require, they too go down by 1. And the function call, of course, it also becomes thinner and more compact, because I have to pass one less argument while I call these functions. And well, the output actually remains the same. You can see the changes in the definition. Actually, the only thing that is changing is the header, right? You can see that I have removed the str variable from the header. So now there's one more storage class that you need to know about. It's known as the static storage class. So an advantage of these global variables is that their values persist across function calls, right? So when I say persist, it means that unlike the auto variables, whose values are basically lost, okay, as soon as the function ends, or the function returns, as this is what we usually call. uh, this is what happens with the auto variables. The global variables, their values, the place wherever these values are stored, it's managed in such a way that that place is not cleared as soon as a function returns, right? So that the values remain um, available to you for use again, during a next function call. The disadvantage, of course, is that global variables are accessible to all the functions in your program. So you cannot, for example, stop your global variables use in certain functions and allow it in certain others, right? So global means it's available to everyone. Sometimes, in certain conditions, you actually wish to persist a particular value across you know multiple invocations of the same function, right? But you don't really want the value to be accessible outside the function. So for that, of course, you can always do that using the global scope, if you don't want the value to be if you don't have a problem with the value to be shared with other functions. But if you want it to be restricted to the function where you require it, then there is one more option that you get, and that storage class is static. Okay, so static variables are somewhat in between an auto and global variable. What happens is, um, if you create a static variable, within the function where you are creating it, it behaves pretty much like an auto variable. So you can use it, you can read it, assign it, whatever you want. But when the function returns its storage, whatever place, wherever it is being stored in the memory, that place is not cleared. Okay, so when you make the call to that same function again in the program, you can basically use the value that you actually set the last time. So this is a simple example. What we are trying to do is just we are just trying to create some kind of a stopwatch. It is not really a stopwatch, because in stopwatch, you start the watch and then you stop it. Here we just have a click. Okay, so there is a click function. What this click function does is that it returns the rough amount of time that has elapsed since the last click happened, right? So basically this is the idea that if you keep on doing click click click, it will just return you the amount of time that has elapsed between the last two clicks. That is the idea. So what I'm trying to do here is I'm creating a static variable called prior within this function. So as you understand, the value of prior will persist across multiple invocations of click. And another property of these static variables, something that is much more different from the auto variables, is that they always get initialized with a zero, right? So this is a problem that we have seen many a times. If we are not careful, we just simply create a variable, and we do not assign a value to it. So then what happens is that we get some kind of a garbage value. But with static variables, you're guaranteed that this particular variable will always be initialized to a zero. So now in the main, what we do is we actually make three calls to the click function, and we actually try to do some artificial work in between as well. So basically, I think in this loop, I'm counting down from 1 million to, is it 10 million? Okay, yeah, it's 10 million, right? So I just count down from 10 million to 0, and here I'm just counting down from 100 million to 0. So just some artificial work, so that we can see uh, the differences in the time. Otherwise this program will run just too fast, right? And you won't be able to see any output whatsoever. Now each time what happens is that we create a new timestamp. We find the current timestamp that is there, and then we just take a difference between the timestamp that is there currently and whatever it was in the last time, in the last invocation. And after that we just assign the current timestamp to this prior variable. So now this particular value will be accessible to us when we call this click function again, right? So, and this is why we are able to get the difference between the last invocation and the current invocation. So this is the whole thing. I should have probably included a slide on the output as well. I'd include it in the slide, before I put it on Google Drive, just to get an idea. But by the way, I do encourage you guys to uncomment these statements, and then just see how the value of prior is retained. Okay, so this is the whole idea of a static variable. Now, there is of course something that is a little more advanced, the amalgamation of extern and static. A lot of people use extern and static together for certain purposes. Now, because we have not actually seen the whole process of breaking a C code across multiple files, that all these details might not be of much importance to you. I'm not teaching these things because I'm not expecting most of you to become advanced C coders, but still, in case you are planning to uh, work in C or C++, you will actually see the static and extern keywords being used together multiple times. In fact, if you just open some of the header files that are there, you'll find static and extern very very commonly being used together. So I'm just including some information here for the sake of completeness. Even if you don't understand it, it's fine, right? It's just some kind of completeness thing that I'm trying to include here. So a global variable which is declared in one particular C file, it can actually be used in other C files as well. So if you link them together during a build process, a global variable created in one C file can actually be used by code in another C file. In this case, you actually need to provide a declaration for that variable in each file where you are planning to use it. You can do that by putting the extern keyword before the declaration, just extern and then the declaration. This is not required for functions because by default all the functions are essentially global. Okay, so the extern thing is implicitly applied to all the functions. So if you want but in certain cases, I'm not going to go into greater detail, but in certain cases, if you just want a global variable to be accessible within the same file, within the same C source file where it has been defined, if you make it static as well, then it actually remains accessible in only the functions that are defined in that particular C file. You basically switch off its access to any other function, any other place other than the C file where it has been defined. So these are some of the things that I've simply um, added towards the end of the lecture, so that for those students who would like to explore more, they can actually go and do that. But don't worry if you don't understand these parts, it's completely fine. There is some homework, have a look at it, and we'll discuss this in the class on Tuesday. Thank you. Bye.